So is it true that the quantity of x plus 3 squared is the same as x squared plus 9? Well, to the young Padawan, it may be tempting to make this assumption, but let's just consider, let's say, hey, let's let x be 2, right? So if I'm looking at x as 2, on the left-hand side, this becomes 2 plus 3, and when I square that, which is 5, I get 25. Now, on the other side, right, if I take this 2 and I square it, that becomes a 4 plus a 9, and 4 plus 9 is the number 13. Well, I can tell, you know, either this is always true, right, or it's not true. This can't be, true some of the time. It could be true some of the time, but it's not sufficient just for it to be true occasionally. If we're claiming that these are really equal, it has to always be true. So I would say because 25 is not 13, these are certainly not the same, right? They're different from each other. So that's one justification that they're not the same, because just consider a value of x. Now, you can see if you're unlucky, right, if you were to pick x as 0, certainly it does become 3 squared, which is 9, right? So on the one side we get 9, on the other side we have 9. So it works apparently when x is 0, but that's not enough. For these to be truly equal to each other, it would have to work for all values of x. Now, why is it the case that it's not? Well, if we were to look at the area model that we've been talking about, and I take something like an x plus a 3 and I square it, which means I multiply it by itself, I get the 4 distinct regions. I get an x squared. This area is 3x. This area down below is 3x. And this area is 3 times 3, which is 9. So when I combine those 4 pieces, I get an x squared plus 6 times x plus the number 9. So what we were missing is there's this 6 times x that's missing. So my justification would be, I could probably write down 2 things. First of all, it doesn't work when x is 2, and also when I square x plus 3, I get x squared plus 6x plus 9. And the only time that x squared plus 6x plus 9 is the same as the quantity of x plus 3 squared is when x is 0. So these are not the same, and this is not true.